So good afternoon everybody, myself Acharya Vishvendra, and today I am going to discuss a question on the topic of momentum. So let's begin with the question. The question is, a particle is moving on the curve given by y is equal to 1 by x, which is a rectangular hyperbola, and at a certain point its speed is v, and v here is given to be 10 meter per second, and we need to find velocity when x is equal to 2. So suppose at this point x is equal to 2. So we need to find velocity in vector form in this case. This is x, y, z. So before starting this question, just give it a thought. We are being given the velocity and we need to find the velocity vector. Magnitude of velocity is given as 10 meter per second. So for finding any vector, we need to find its magnitude as well as the unit vector. So magnitude we have. So the task is to find the unit vector along velocity. So what we can do is, we know that velocity is tangential to the curve. So if I find this angle, let's say this angle is alpha, then I can resolve the velocity vector along tangent in the two perpendicular directions. And using the concept of resolution of vector along x-axis and y-axis, I can find the unit vector along the velocity. So this is the concept behind solving the question. That first of all we will find this angle alpha, then we will resolve velocity, and by virtue of which we will find the velocity vector, you can say. So let me approach by this method. So we can say that velocity can be written as, let us say this angle is alpha, so by resolution we have this as v cos alpha and this component as v sin alpha. So in proper vector notation we can write vector v is v cos alpha into, here is unit vector will be I plus v sin alpha, here unit vector will be minus of j. So this is the primary design of the solution, and velocity will be like this. Here v we know as it is equal to 10. So we just need to find angle alpha. Now think again how to find angle alpha. So angle alpha can be found by the slope of tangent. So we know that dy by dx will be minus of tan alpha. So this is how we are going to find it. Now y here is 1 upon x. So we can say that dy by dx of 1 by x is equal to minus of tan alpha. So if we differentiate 1 by x, we have minus 1 by x square is minus of tan alpha. Now x here is given to be 2. So if we substitute x is equal to 2, we get tan alpha as equal to 1 by 2 square, which is your 1 by 4. So tan alpha here is 1 by 4. So now tan alpha is 1 by 4. So we can say that this is alpha, this is 1, this is 4, this will be root under 4 square, this will be 17. So from here we can say that cos alpha will be 4 by root 17 and sin alpha will be 1 by root 17. So substituting the value, we get v is equal to v cos alpha I cap plus v sin alpha into minus of j cap. V here is given to be 10. So from here vector v can be written as 10. Cos alpha is 4 by root 17 I cap plus 10, sin alpha is 1 by root 17 minus of j cap. So we can say that velocity will be 40 by root 17 I cap minus 10 by root 17 j cap. So this is the velocity vector of this particle at this particular instant. So you can see that this is a mixed question, this is a multiple concept based question. First concept is of the resolution of vectors, second concept is of differentiation, and third concept is relation of differentiation and slope of tangent. So by integrating all these concepts is a tri-conceptual problem. So by integrating this expression we come to the conclusion velocity is equal to this. Now the next task is to find momentum. So we know that momentum is equal to mass into velocity. Mass here is given to be 3 kg and velocity we have calculated as 40 by root 17 I cap minus 10 by root 17 j cap. So on solving this we have 120 by root 17 minus 30 by root 17 into g. So this is gonna be the momentum of the particle at this particular velocity. Third question is find the magnitude of momentum. So magnitude of momentum will be root under 120 by root 17 whole square plus minus 30 by root 17 whole square. So in this way we can find the magnitude of the momentum. I'm not going to solve this out because the most important point was to design this solution for finding the velocity. Because it's a triangular concept, we have to integrate three concepts. First one is related to the resolution of vectors, second is related to differentiation, and third is related to the relation between differentiation and slope of tangent at a particular point. So if you are comfortable in all the three concepts, then you can easily integrate them to find solution of this particular question. So these questions are typical questions which are asked in JEE Advanced Physics because it tests the skills of your mind and system, and the fundamental skill is to integrate the fundamental concept to use multiple concepts in a problem by integrating them within a desired time. So generally there is a time limit of let's say 3 to 4 minutes because 18 to 20 questions are asked per week. So that sounds to be 3 to 3.5 minutes per question. So time is a bit more in that because here the concept is not of speed, but here the concept is of your capability to fetch the multiple concepts and to retain the fundamental concept, integrate them as a whole, and to decode the problem as we have seen in this particular question. The rest of all is very simple. It's very basic concept. The three concepts you must be very comfortable with. But when you are asked to design solution in a complex problem, that means you need to integrate your learning to form a very complex pattern which is capable to solve this particular question. So that is so special about the advanced physics because here questions are new. You can't, it's not based on any pattern. So you can't predict it out. There are very less questions which are pattern based that you can practice. Generally questions are new and you have to start with the first principle if you are thorough with the thinking process. If you start a problem with the basic thinking, with the fundamental thinking, if your fundamentals are strong, then certainly you can make the question. But generally pattern based questions are not asked in JEE Advanced. They are still a substantial part of questions are asked in JEE Main and NEET, but JEE Advanced is a different game. So it's based on your capability to design solutions of the new situations. Obviously, new situations have something to do with the cases that you have done, but they are distributed concepts. One concept is from let's say calculus, another concept is from let's say vectors, another concept is let's say from the friction. So you need to be diversified in terms of the problems you are working on. So the crucial factor here is your capability to think in a diversified situation, to think globally, to interrelate different concepts. So that is the key concept.